Share screen. Where's share screen? There it is. All right. Sorry about that, guys. We started going without a video, but now it's up. Hey, so you got to know theoretical yield, experimental yield, and percent yield today. That's the only thing we're adding new. And really, we're not adding anything new except for percent yield because the other two we kind of should understand. If you do the calculation, if you do the math, and you do it on paper, is that going to be theoretical or experimental?
Theoretical.
Yeah. Everything we've done in this point so far, up to this point in class, is theoretical. Now, for experimental yield, that's what you would actually get if you did the experiment. You did this, you literally took 30 grams of whatever and mixed it with 20 grams of whatever and saw what came out, then you would get the experimental yield. The difference between the two is your percent yield. Percent yield is actual over theoretical or experimental over theoretical. Okay, so the experimental yield over the theoretical yield gives you your percent, and you're going to get a decimal number. Now, my daughter's in the 7th grade. She's doing percents like crazy. Everybody understands how to get a turn decimal into a percent.
No. Wait, yeah, you multiply.
What percent is that?
98.
98%. What percent is that?
2%.
2%. Okay. What percent is this?
103%.
And would that be possible?
Yeah.
Can you get 103% of what is possible?
Yeah. Wait, no. It's just
You don't
what's
have
possible.
Yeah, so that's like a scientific pet peeve. It's one of my pet peeves where somebody says, I'm giving 110%. It's impossible. Because 100% is all you can give. If you can give 110%, then you were lying about 100%. Does that make sense? Okay, so percent yield is all about your experimental yield over your theoretical yield. What you actually get over what you get if you do the math. Which of these numbers should always be higher? Yeah, theoretical yield should always be higher because that's if the experiment works perfectly. If every molecule hits every molecule and the reaction works perfectly, that's your theoretical yield. What you get in the experimental yield is you're going to get less because maybe you didn't let the reaction finish, or maybe you didn't measure it correctly when the time came. Experimental yield will always be less. So let's do an example of that when we have on the board here. So this is your first example on your practice. So if you do this with me, you will have gotten 1 out of 5 questions right because there's only 5 questions on your practice. This is the first one, okay? First thing you need to do, Josh already mentioned it, you gotta make sure we're balanced. 1 lithium, 1 lithium, 1 oxygen, 1 oxygen, 1 hydrogen, 1 hydrogen, 1 potassium, 1 potassium, 1 chlorine, 1 chlorine. Ka-chow. Okay? So it should be all of your ratios should be what to what?
1 to 1.
Yeah. So we got that math is going to be pretty easy. Okay? So we says I began this reaction with 20 grams of lithium hydroxide. Okay? What is my theoretical yield of lithium chloride? So the only thing we've done so far is change how much lithium chloride am I going to make to what is my theoretical yield. You just change the word. The how you do it is the exact same. 20 grams of lithium hydroxide. First thing I'm going to do is change that grams of lithium hydroxide to moles. Grams on the bottom, moles on top. Okay? Somebody ready with the calculator? Okay, I'm about to tell you. Okay, so we want grams of lithium hydroxide in 1 mole. So lithium is 6.9. So give me 6.9 in the calculator. Oxygen is 16, so plus 16. Hydrogen 1 plus 1. 6.9 plus 16 plus 1.
23.9.
Okay, I'm saying?
23.9.
23.9, go ahead, Mr. Stein.
Why would we not go ahead and round lithium up to 7?
1 number past the decimal.
Okay.
If it was 6.95, 7.
Okay.
But that 6.94 means keep it at the 1 number past the decimal. And if you did, your numbers will probably be off a little bit, but I'll still kind of right. Okay. I'm not grading by rounding ever. Okay. So that gets me to moles of lithium hydroxide. I don't want to talk about moles of lithium hydroxide. I want to talk about moles of lithium chloride. So this is where we get to our easy math. What's my ratio?
1 to 1.
1 to 1. 1 mole of this guy to 1 mole of this guy. But I don't want moles of that guy. I want
Moles of the other. You want grams?
Grams that I got. Moles on the bottom, grams on top. Ready with your calculator? Once again, lithium is 6.9. And we're going to add chlorine, which is 35.5.
42.4.
All right, and then I'm going to take a pause. Because I know I'm talking fast today, but let's make sure everybody's with me. Now, if this is a 10-point question, okay? If this question is worth 10 points on your test on Thursday, you just got 9.
9?
Because this ain't math class. Because everything else is math class. You with me? Everything else, I mean, if this is chemistry. We're done with chemistry. Now we got to take math. And we just got to solve this problem. We're going to do our multiply. We're going to divide it. Which we're going to do first? We're going to multiply 20 times 42.4, and then smash my enter button and divide by 23.9.
35.5.
Yeah, let's make sure everybody agrees. Everybody cool?
Yeah.
35.5 grams is what I'm doing, and now that's part A of my question. That is my theoretical yield. Now, the question says, I actually produce only 6 grams. Yeah, I agree. If your actual production was only 6 grams, you have messed up somewhere. Okay, but we got to figure out what my percent yield is. We're going to take my experimental, put it on top, and my theoretical, put it on the bottom. You tell me, what do you do? Come on, bro.
So I do 6 divided by 35.5.
6 divided by 30.5. Off the top of my head, just looking at it, my guess is going to be about 0.18, 0.17, 0.16, close in there. So 0.169, let's say 17%.
Yeah.
That's your percent yield.
That's it.
That's it.
Man, that is crazy. You gotta do a whole, you gotta do stoichiometry. You gotta do that.
And if you look on the rest of them, number 2 is almost exactly the same as what we just did. And let's do number 2 together because it's kind of backwards. But number 3 and 4, they give them to you. All you have to do is the percentage. So you don't even have to do any extra math for 3 and 4. And then we go back to normal on number 5. So I'll do number 2 with you, and then I'll let you knock out 3, 4, and 5. Questions on what's on the board? All right,
I got a question.
Go ahead.
But
well, go ahead.
So how? Okay, I gotta do all the stoichiometry stuff. Like every.
Back, yeah, which is what we just did right here.
Yeah, I know. But like, I gotta do every part of it that we did last week.
The more you practice, the easier this will be. And it's only 4 or 5 questions per practice thing.
Yeah, I know, but I gotta do all of them.
It would help you.
Yeah.
All right. So let's check out number 2. All right, number 2, they already balanced it for us, but we'll double check.
So do we have to write number 1?
I mean, same as always. Well, actually, you weren't here. I was about to say same as last week, but you weren't here last week. Anytime we got write out problems that I'm gonna say, like, take a picture of it to send it as your homework. If you show it to me in class, or if I see you working on it in class, I'm gonna give you credit without worrying about a submission. Okay. All right. So we got C3H8. We're gonna add that to 5 molecules of oxygen. And it's a combustion reaction, so we're going to need carbon dioxide and water. 5H2O, nope, 4H2O. All right, let's double check, make sure they did the math right when they balanced it. 3 carbons, 8 hydrogens. 4 times 2 is 8 hydrogens. 5 times 2 is 10. 3 times 2 is 6, plus 4 is 10. So beautiful, they did it right for us. We're starting with 5 grams of this guy. And it says, what is the theoretical yield of water? And it doesn't ask for grams, but then in B, it does ask for grams. So, we need to make sure we get that. Okay. So we got 5 grams of C3H8. What's going on the bottom? And we're changing it to moles. Here's one thing that happens a lot for this test. People can start it, people set it up, people draw their fraction, and then they say, well, I know I don't want grams, so I put grams on the bottom. What do I change it to? 95% of the time, the answer is changed to moles. Moles will take you anywhere you want to go. If your question doesn't give you moles, odds are the very first step is you need to change it to moles. Okay? So I don't want grams, I want moles. And if you're going from anything that's not moles to moles, it's always 1 mole. So we need some math real quick. 3 times what is carbon? 12. Y'all did that in about 3rd grade. 3 times 12 is 36. 8 times.
8 times 4.
Look again.
Wait, 8 times 1.
8 times 1 is
8.
8. 36 plus 8.
44.
Rock and roll. Y'all feel good? Feel free to confirm it with your calculator. All right. That gets me to moles of C3H8. I don't want to be talking about C3H8. I want to be talking about water. So my moles of C3H8 on the bottom, moles of water on the top. And where am I going moles to moles? What numbers?
1 and 1.
Look again. No, that's grams.
1 to 4.
1 to 4. Excellent. 1 for this guy, 4 for this guy. If you're going from moles to moles, you're using your coefficients from your balanced equation. Anybody want to major in science of any type? Okay. I majored, my degree, my first degree was biology. So I majored in biology. If you take any science, you've got to pretty much take a couple years of chemistry beyond what you did in high school. You use this next number so much that you just know it. Okay? Go ahead.
What do y'all talk about in biology?
And like what?
Biology.
The science of life, cells, living things,
It's mainly cells.
You know, genetics.
Like, is there a certain credit you have to be in to take it?
You take it next year.
Last year.
Well, I mean, but 8 years we go earth chemistry, bio for most folks.
Yeah.
But good. And then you come anatomy your senior year. What it means. All right. So I got one more of this guy. The reason I brought all that up is because, like I said, you just memorize water after a while. It's a pretty easy one to do though, because H is 1. 1 times 2 is 2. Plus 16 is 18. All right. We got to math this fool up. What we're going to say, 5 times
5 times 4 times 18.
5 times 4 times 18. Smash my enter button and then
Divide by 44.
divide by 44.
8.2.
Got to vote for 8.2, but let's make sure. I want everybody to see it. Don't trust the Styron's calculator. Your calculator might be different. Let's make sure we got the right thing. Got 8.2, but let's confirm.
Got 8.1.
Rock and roll. Got agreement back there?
It's 8.1.
Okay.
8.18.
8.18, 8.2, what?
Huh?
8.2 what?
Grams.
Grams.
Water.
Grams of water. Excellent. Now, look at my question there. Question B says, if you get a percent yield of 75%, which is 0.75, then how many grams of water did you actually make? Okay, a lot of people craning their necks. I'll give you some room there. Okay, so remember your formula. Theoretic, or experimental over theoretical equals percent. Okay, so what is 8.2, experimental or theoretical?
Theoretical.
It's theoretical. I did it on paper. I didn't actually do it. So 8.2 is on the bottom of a fraction.
So how to get it backwards? You get theoretical times.
And then my percent is 0.75. And to do that math right there, you're just going to say
8.2 times 0.75. 6.15.
6.15 what?
Grams.
That's it. Like I said, 3 and 4 are pretty easy because you're just dealing with the percentage. You don't have to do any other calculations. You just do that last step.
They did
And then
that.
5 takes you back to what we just did a couple times.
They did that experiment pretty good. Not like the first.
Yeah, that one was a whole lot. 75% error is a whole lot better. And the reason you need to calculate percent error is because I got an example of this that I used to use in my normal slides. And there's when you go in the spaceship, okay, what do you got to do to keep people alive? You got to make sure they get oxygen. But if I lock the door, seal this room, if I seal this room so no air could go in or out, we wouldn't die from lack of oxygen.
You would die of like carbon dioxide poisoning.
Very good. You would die from too much carbon dioxide. So I can give you all the oxygen in the world. That don't matter if I can't do what?
Get rid of that carbon dioxide.
Very good.
That acid.
So one of the biggest chemical reactions they have to do on a spaceship or on a space shuttle is a chemical reaction to scrub the carbon dioxide, to get the carbon dioxide out of the atmosphere. And they have a chemical reaction that does it. They change the carbon dioxide into water pretty much. And that reaction, when you do it on the space shuttle, is only about 80% yield. So if you calculate it out and assume it works perfectly, you actually end up killing astronauts because you have to calculate it out to the percent yield that it actually works by, not the theoretical yield. Does that make sense? All right, questions?
I don't have a question number 3.
Okay. All right, guys, I'm gonna shut down the Zoom. I hope y'all enjoyed it. Don't forget, if you're watching this video on the 3rd, on Tuesday, today is your last day to turn stuff in. Make sure you have stuff in before tomorrow morning. Tomorrow morning, I'm going to finalize your grades, and that's what you're going to have for the second 6 weeks. Have a great day.